Did you know that computers don't count like we do? Instead of using 0 to 9, they usually use two numbers, 0 and 1. This is called the binary system. Our number system is a decimal system base 10 digits from 0, 1, 2, 3 all the way to 9. While for computers, the number system is binary, base 2, digits 0 and 1. Computers store data as 1, on or off as 0, just like light switches. Every 1 or 0 is called a bit. In this video, we're going to learn how to convert binary, the language of computers, into decimals, the numbers we use every day. Let's start with the first example and let's go into the key idea of place value. We have the example 345. If we want to represent this as place value, we will do 3 times 100 plus 4 times 10 plus 5 times 1. But here, place values are powers of 10. We will have 10 to the 0 power, 10 to the first power, and 10 to the second power. But in binary, using the example 1011, so we start with 2 to the 0 power, 2 to the first power, 2 to the second power, and 2 to the third power. Now, because the binary number 1011 has 4 digits, so we will write 2222. We will write 4 2's matching the number of digits for the number 1011. But we start with 2 to the 0 power always, increasing 2 to the first power, 2 to the second power, 2 to the third power. Now, knowing this, we need to calculate these powers. 2 to the 0 power will be 1. 2 to the first power will be 2. 2 to the second power will be 4. And 2 to the third power will be 8. Now, knowing what the powers of 2 are, we need to multiply the binary number 1011 with the values of the powers of 2. So 1 times 8 will be 8. 0 times 4 equals 0. 1 times 2 equal 2, and 1 times 1 will equal 1. Then we need to add up. We add 8 plus 0 plus 2 plus 1. This will add up to 11 as our final answer. Now, I will give you the step-by-step method that can help you convert any binary number to a decimal number. Write these steps on a piece of paper and simply follow them. Now let's work on more examples. Convert the binary number 1010 to a decimal. So this binary number has 4 digits. Now we always start with 0. 2 to the 0. We increase to 1, 2, and 3. Now we need to calculate these powers. 2 to the 0 power will always give you 1. 2 to the first power will give you back itself 2. 2 to the 2 power, we need to multiply 2 by itself 2 times. 2 times 2 will be 4. 2 to the third power, 2 times 2 times 2. 2 times 2, 4. 4 times 2 will give you 8. Now, knowing these values, we need to multiply it with the binary number 1010. We have 1, 0, 1, 0. Now 1 times 8 will be 8. 0 times 4 will be 0. 1 times 2 will be 2. 0 times 1 will be 0. Now we add these values. 8 plus 0 is 8, plus 2 will give you 10. Here's another example, 1101. This binary also has 4 digits. We have 1, 2, 3, For 2, we always start with 0. 2 to the 0 power, 1, 2, 3. Next, we need to calculate these powers of 2. 2 to the 0 power will be 1. 2 to the first power, 2. 2 to the second power, 4. And 2 to the third power, we know it's 8. Now, we take the binary number 1, 1, 0, 1, and we multiply them with the values of the powers of 2. 1 times 8 will be 8. 1 times 4 will be 4. 0 times 2 will be 0. And 1 times 1 will be 1. Now, let's add 8 plus 4. 8 plus 4 will be 12. Plus 1, it will be 13 as your final answer. So it means that this binary number represents 13 as a decimal. Solve the binary number 100,101. Let's count the number of digits. 1, 2, 3, 4, 5, 6. This has 6 digits. 1, 2, 3, 4, 5, 6. We always start with 2 to the 0 power and we increase 1, 2, 3, 4, 5. Now we need to calculate these values. 2 to the 0 power will be 1. 2 to the first power, 2. 2 to the second power, 4. 2 to the third power, 8. 2 to the fourth power, 16. And 2 to the fifth power is 32. Now we know our values of the powers of 2. Now we need to take the binary number 100,101. 100,101, and we need to multiply it with the values of the powers of 2. 1 times 32 is 32. 0 times 16 is 0. 0 times 8 is 8. 1 times 4 is 4. 0 times 2 is 0. And 1 times 1 is 1. Now, if we add 32 plus 4, that's 36. Plus 1, our final answer is 37. Therefore, this binary number here represents 37 as a decimal. Always remember to begin with 2 to the 0 power. Always multiply and then add to get your final answer. Now here, I'll give you some practice problems. Pause the video and convert binary numbers to decimals. I will go ahead and give you the final answers. The binary number 1111 will give you a final answer of 15. The binary number 101101 will give you the final decimal number 45. The binary number 10000 will give you 16 as your final answer. The binary number 110010 will give you 50. Now you know how to convert binary to decimal. If you want more practice, check the comments below or check the description. I will put a link below. You can download a PDF and work it out yourself. It has only final answers for each problem. Remember to give this video a like and leave a comment below. It really supports the channel.